first thing I've done is stated the three equations. I'm going to show you what I've done with the first and the third, but I'm not going to show you what I've done with the second. That's how I'm going to reach the compromise. I'm going to explain what they are and talk through the process and talk about why we're doing it. What's the reasoning behind this? So the first thing I do is I list my three equations. I'm going to sub Q equals mc delta T into my thermal conductivity equation. So as you can see in the red here, I've got where I've subbed that in. So all I've done is replace Q with mc delta T. We call that substitution. That's why you don't muck around in this class, all right? They're sorting out the kid from last class who wouldn't stop calling out.
Cool.
Now, once I shove that value in, I've got an even grosser looking equation. But thankfully I've got my dependent variable. Because when we do this experiment, what are we measuring? Temperature. So on the task sheet we've got heat energy, but we can't measure heat energy. So our research question should reference heat energy, but how are we going to identify the change in heat energy? By measuring the temperature. So we want to find the relationship between the change in temperature of our steak and area or thickness of our steak. Clear. So we want to get delta T by itself because we know when we're graphing y equals mx plus c. What's y? The y-axis is our? Y-axis is our? Dependent. Okay? So that's the one that we're measuring, the one that we're trying to figure out. The one that we're changing is our independent variable. Where does that go? On the x-axis. So when we rearrange this equation, we want to get delta T by itself. Please don't confuse the delta T in this equation with the change in T in this equation. The blue delta T, or change in T, I've represented it as T2 minus T1. Some websites will represent that as delta T. All it's saying is the difference in temperature between the barbecue and the steak. We're assuming that's constant. It won't be. I'm telling you straight out, it will not be constant. Mathematically, you can't deal with that yet. But it's a good experiment, so I thought, why not? Plus, depending on which one you've chosen, that might give you something to talk about later on in your experiment, depending on which variable you've talked about. So once I've isolated my variable delta T, I'm not going to do that on the board. Are we clear? Once I've done that, I should have a whole bunch of things. Delta T, and I'll do it down here, delta T equals blah, 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 blah. I don't care what it is. But whatever it is, it's going to have an A, an M, and a D. And all the other stuff. What's the thing with all the other stuff? What should that all be? Constant. Now, if I'm changing my area, what does that mean about my thickness? It's also in that group. Does that make sense? So for this example, I'm just going to assume I'm changing area. It doesn't matter. Can we see what the problem is?
Yes.
What's the problem?
You've got two variables that aren't constant.
We know that as I change my area, I'm going to be changing my thickness. My mass. And if I'm not changing my mass, I'm changing my thickness, which is a bigger problem. Just trust me. You have to keep your thickness constant. But I would argue that we're not changing our mass in a way that we can't predict mathematically. So the problem in here lies that we normally want our equations to have delta T equals everything that's constant multiplied or divided by our dependent variable, A or D, depending on what it is. Clear? But in this case, we haven't got that. We have two things that are changing. But I would argue that we don't. This is where this equation comes in. You need to think about how you can use equation 2 to help you fix up this problem. You will need to use substitution, just like I've done. Same process, different variable. I've left you a step or two away. There's at least 2 steps that need to be fixed up. You need to think, and you need to think about the shape of your steak. You can control the shape of your steak, can't you?
Yes.
So maybe when you're thinking about the modifications to your method and adding a justification as to why you're changing your method, I'm hoping that you will use this step with this equation to clearly identify a change in your method, and hopefully it'll help you get a clear relationship between delta t and your variable a or d. This will be a linear, inverse, polynomial, or no. Now just be aware with inverse, it might be inverse, squared, cubed, whatever it might be, or no relationship. If any of those, they're all fine, okay? If any of those pop up, you're in the right spot. If that's your predicted relationship. Clear? All of those are acceptable relationships. Well, not all, some aren't. But if you get one of those responses, don't freak out. Sweet. The reason we do this is because once we get our graph and we plot our data, we can say, hey, my data says it should be linear. The trend line says it should be linear, but mine's giving me a polynomial. And we can talk about why. Year 7 kids say, both went up. Year 8 kids say, both went up, but mine went up faster. Year 10 kids talk about the difference in the trend line and what this means for future. Year 9 kids, I don't know what they say.
They just don't do it.
Do they say anything?
No, they're just too busy.
They're too busy doing woes and stuff. Alright. I hope that clarifies a little bit more and you've got a fair point to start on.